Good evening, sir.
Yeah, good evening.
Sir, I'm sorry, sir. I had an exam today in the afternoon. I was coming back from COET, sir.
Okay, so you have exam tomorrow, is it?
No, no, sir. The exam is done, sir. It was in the morning.
Okay, so yeah. Um, okay, we covered the binomial theorem. I think everything we covered in there. Just some of the topics were left. Okay. You tried to solve some problem based on those.
Yes, sir. In the NCRT, sir.
Okay, you were able to make all them
Yes, sir. I could do them, sir. Except like you said, there was one question from
complex.
complex numbers. Except
Yeah.
that,
Okay. I'll leave that part. Okay. What I will do today. I'll complete the rest of the portion of the binomial. Okay, after that, it's up to you whether you want me to continue with the new chapter. Okay, or else we'll end by the binomial. Okay, so
okay,
I'm not making a new page. I'll continue with this part itself.
okay.
Okay, so in the previous class, we discussed the binomial till middle term expansion. Is it?
Yes, sir. And general
Okay,
term also.
yeah, in general term. Okay. Now, just think of it. Whatever we have discussed, if I put n equals to negative in those, for example, I discussed, I used this formula, right? Where is it? I'll just go with the name. Binomial expansion was there. What formula we had for that?
Sir, are you sharing your screen?
Okay, sorry, I forgot to share the screen. Uh, Maybe now it's fine.
Yes, sir. Now it's fine, sir.
Yeah, now it's fine. Okay. So look, what is the formula for binomial expansion? So it's like you're having okay, what we had to do, we had to calculate a b to the power n, right? And now if my n was positive, if n is greater than 0, means to be say positive or equals to, you can put it, so it is nothing but nc r, not ncr, actually go with the 0, a to the power, I can call it as n, b to the power 0, 2 to 2, where you are going to go, n c n a to the power 0, b to the power n. Yeah, this is what we are going to do. But what do you think? Will it be applicable if I say, okay, my n is negative right now? What if the case comes out if n is less than 0? Because if n goes less than 0, for less than 0, we don't have a factorial present, right? Because for 0 factorial comes out to be 0, it's 1 itself. But we never discussed about minus 1 factorial, minus 2 factorial, and all.
Yes, sir.
So how we should solve this? Do we have any another method which can represent the which can solve our problem? Okay, so for this, what we do now? We have another method to solve it. Okay, what is that method? We starts by saying, just take this formula carefully. What I have to calculate? I have to calculate this part, right? Start with one, not one actually. A to the power n. Okay, start with a to the power. We generally start with a to the power n and with b to the power n. Is it
Yes, sir.
the same? We have to plus. What should be the next thing? A to the power n minus one, b to the power one. I can say.
Yes, sir.
Okay, but there's one more thing. That is n factorial along divided by one factorial. Clear?
Yes, sir.
Here actually 0 factorial was there, but 0 factorial is 1 itself. Okay, so we are not representing that. So what should be the next? N, okay, we have to add it up. N, n minus 1 divided by 2 factorial. Okay, okay, one more thing. It should not be n factorial, it should be only n. And here it should be n minus 2 b2 plus n minus 1 n minus 2 divided, because look, whatever you have taken, just succeed by negative 1, n minus 1, just succeed by negative 1, this, and whatever here is the max, you can put it down also. No, the addition of n down also. So here it will be n minus 3 b3. Is it clear?
Yes, sir.
Till where we can go?
Till b power n into
Look, that we don't have actually idea about this. The reason behind that, what do you think? Do we have any particular value? Yeah, we can have. What I can say, I'll be going till n minus, I can say 1. Okay, then I can say n minus r plus 1. This is what we are going to. Okay, till there I have to be. I have to be. Also, this is my formula should be, and it should be divided by r factor. Is this clear?
can you explain the last one once?
Last one.
Yeah, the n into n minus 1 into n minus r plus 1. That one, please.
Okay, this is the formula. Like this is the final formula you'll be getting. Basically, the same thing is applied here also. All these places.
Okay, so it's like the general term, let's say.
Yeah, it's a general term. Okay, I'll get the general term out of it also.
Okay, okay.
So what is the general term? You could have got the idea. So my general term should be, yeah. Wait, just a second. There should be a n to power minus r b to the power r, because this is r and I'm going with. Is it clear?
Yes, sir.
Like if you see carefully, what is here I have? Here I have nothing but whatever n I had minus this r 3 plus 1. Isn't it the same thing? N minus r plus 1.
Yes, sir, but shouldn't there be like n into n minus 1 into n minus 2 into so on, and then n into n minus
No, no, no. It won't go till there. Actually, what happens now? Till previous now, we don't had option to put that thing here. You're getting point.
okay, yes, sir.
Here we don't even like here. Here R was not even such that I can have this value. Make sense?
Yes, sir.
So these were the things.
So, but like here, in the last term, sir. So why are we not writing the n minus 2 into n minus 3 into like so on and so forth until n into like in n minus r plus 1?
Okay, here why we are not going from n minus 1? Is it you are asking?
Yeah, there should be into n minus 2 into n minus 3 so on and so forth until this term, right? The n minus r plus 1 term.
It's a long derivation. Okay, this is a direct given result out of it.
Okay,
Okay, it's like long derivation for this.
okay,
Like it's like we'll be solving this much more and we'll get some result like this. So that's I'm providing a result to you. Okay, so whatever you are going to get, it is n. I forgot what it is. R and b to the power r. Okay. So if I ask you what is the general term, so you can call it as n minus 1 n minus r plus 1 divided by r factorial a n minus r b r. Okay, look, the reason you can also say it is not going in this way because it's not a normal factorial, right? In normal factorial, if I had 5, I had 4 present to get factorial, I had 3 present to get the factorial. Here it can be minus 5. We don't have factorial for minus 5, right?
okay. Yes, sir, I understood, sir. Got it.
That makes the things different, whatever the scenario we are going with.
Yes, sir.
Just a second. Okay. uh, I think it is correct. Not able to erase it. Okay, leave it. Actually, that was correct. We don't have to remove this. So it is n minus r and b to the power r. Okay. What do you think? Should I write it as n or it should be n plus 1? Not n plus 1 actually. It should be r or r plus 1.
Mm, sir, R
Should
plus.
it be r? Yeah, exactly. It will be r plus 1. Okay. So that's the thing for the negative ones. Okay. I don't think you may have got the negative ones when you were
No, sir.
solving the NCRT examples.
No, sir, we didn't get.
No, you. Right? Okay. Okay, so some theorems are there. I'll go with that, and after this chapter will get completed. Okay, theorem. So what the first theorem is? Disconnected. Maybe from here it will get connected. Okay, so look, the first theorem is all about the n. Okay, what can be the value of n? So if I'm having some real value of n, you know what does mean by real value?
Yes, sir.
Okay, so the first theorem states that if I have any, like whatever the formula we will be using for the binomial expansion, if in that formula I have some real value of n and 1 is equals to, like a is equals to 1, mean to say the first parameter which I am taking is unity.
Yes, sir.
Just a second, I'm not able to connect my pen. It works. It's working, but maybe what I can change. Okay, fine, now it's working. Okay, look, the first theorem states that if you have any, if n is real, okay, and situation is like a equals to 1, theorem with respect to this, whatever I am discussing with respect to this format. Okay, if a equals to 1 and then b equals to x such that mod of x is less than, is it clear whatever I have written over there?
Yes, sir.
If this condition is given to you, so what we can do, anything we can figure out of it. So look, this can be represented as 1 plus a x to the power this. You know, this is what I'm going to get if I just put this same value. What we are going to get, we are going to get this thing. Okay, can we do the expansion of it?
Yes, sir.
Okay, so what I am going to get in the expansion of it will be 1 plus nx plus n minus 1 type of 2 factorial of x plus n minus 1 divided by n minus 2 factorial divided by 3 factorial. Okay, is it clear whatever I have written over here?
Yes.
Okay, how I got this? Any doubt in this case?
No, sir. It's clear, sir.
It's clear, right? I have basically, we have just used the traditional method. It's just a calculated value you have having here. So it is x cube, and here you have. Now just think of it. This is going till infinite value. This may go to infinite value.
Yes.
Okay, if it goes to infinite value, what benefit you can take out of it?
It
You
means
know
like,
that, yeah, okay. You know that the we have just got the uh, th term for this, isn't it? This one,
yes, yes, sir.
for these kind of same expression, I have this kind of t nth term. So
Yes.
let's discuss this a little more. So TR plus, what is it? N minus 1, N minus R plus 1. Okay, it is divided by what? Whatever the R factorial you can. And it is nothing but A N minus, okay, here I had 1, so I don't need to write, I can directly write this. Can I say this?
Yes, sir.
Okay. Now, what benefit I can have about this? You know, I can just remove it for a while because I know the next parameter is always great. It is less than one because I shown you this part. I shown you this portion, right? Okay. Now, what do you think? Is it the whole thing greater than or equals to zero?
Yes, sir.
What can I figure out of this?
It's positive, sir, definitely.
Yeah, I know the total thing is positive, but okay. This is for r is greater than 0. Okay, when your r is greater, basically because we are going with some positive terms. Okay, now if I have something like if my x is very very small, then what I can say in this case?
Sir, for R like very high, like large values of R almost zero.
Yeah, actually what happens when you go in this way? Okay, when you are going in this way, in that case what's going to happen? Your x is very very small, right? So this factor is getting increased by the time, and this factor is getting decreased also because you are having a factorial in below.
Yes, sir.
Can I say by the time you are going further, you are having a more and more factorial. For x, which is very, very, very less than 1, what I can say, we can neglect all these portions. Understood?
Yes, sir.
Okay, this neglection can be there. Why the neglection can be there? Just try to take, okay, let's not take x as a common part. Okay, in this case, just assume we can ignore this portion because these portion gets very small. Okay, which provides no significance with respect to this portion. Understood? You can
Yes, sir.
assume that this thing comes out to be 1,000 and the rest part comes out to be 10 or something. Okay, so you can see it doesn't have significance in front of this. So we can prefer to ignore this part. Clear?
Yes, sir.
Okay, I'm not going in much deep derivation out of it. So you can see I can rewrite this whole thing equals to 1 plus mx. The condition should be x magnitude should be very very smaller than 1. Make sense?
Yes, sir. But in the T R plus one term, like there should be B power R, right? So
Which one?
the general term T R plus one term, and
Okay,
into
this one.
n, yeah.
Yeah, what happened
So there
here?
should be B power like X power R, right?
Yeah, this is also there. I just wanted, look, I know this thing. I'm not discussing about this. I'm just discussing that this portion is greater than 0 or not. Okay, only this
Okay.
portion.
Yes, sir.
That's what. Okay, not the whole thing. Now let's focus on another thing. Just assume you have something like this. Okay, and by chance, if I say, okay, take A as common. So if I ask you if you take A common, what you are going to get? 1 plus B by A. So can you see if you figure out somehow that B by A is very very less than 1, can I apply the same thing here also? AN 1 plus N BA.
Yes, sir.
You can see I have taken the advantage of whatever I have calculated in earlier case. Okay, what is it in the new case? Now you can rewrite the same thing as N B A N minus, right?
Yes, sir.
Okay, I'm not saying you have to mug up all this. I'm just saying if you have got this as result now, you can use it for your work. Okay, you can make it application out of it.
Yes, sir.
Okay, all right. Next, what we can think of it? Any idea you are having?
So like the same if like N
The
is
same way, the same way, the same way. Like in a similar fashion, we have another formula for 1 minus x. For this again, you will be getting 1 minus x. Is that clear? So from here also we will be having 1 minus b to the power n. The result will come out to be how much? Again the same
Uh,
thing, a n common 1 minus n b by a. Clear?
yes,
These
sir.
things are only valid if whatever the next term, if x goes very very less than, mean to say if you are making this kind of term, basically you are taking a as common, so b by a should be very very less than 1. Clear?
Yes,
Then
sir.
only these things are valid. Then and there only these cases are working. Okay.
Yes, sir.
All right. Um, to get this thing, wait, to get this thing, you can assume that b should be lesser than a. Okay, now we have changed it. If this is the case, a plus b to the power n is given. If you see something b is very 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 less than a, you can apply this formula. You don't have to check whether one is there or not.
Okay, sir. Yes, sir.
Yeah? Now I can go and I will check. Okay, let's do one thing. 1 by 1 plus x. How I can solve this? If you know the power is given as n. Now can you solve it?
Sir, it'll be, sir, we learned it in basic maths, like, it'll be 1 minus x,
Yeah,
n x.
basically it will be written as 1 plus x to the power minus n, right? And if I say x is very very small, we can rewrite this thing as 1 minus x. Make sense?
Yes, sir.
So this is what the advantage of taking. Okay, this is the advantage we can take out of it. Yeah. All right. So these were some of the parts I was left to tell you in case of binomial theorem. You know what? How to solve for the binomial coefficients?
So, like, we can use the C, like n, C, R.
Yeah, basically the coefficients, whatever the constant terms come up with, along with the a and b terms, right? That is called as a coefficient. Okay.
Yes, sir.
So I'll just explain some properties of the binomial coefficients. Maybe these can go and helpful for you. Properties of binomial coefficient. Okay. So some property you can call. Okay. First property, C naught plus C1 plus C2 dot 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 dot. Where you can go? You can go to C to the power n. Is it?
Yes, sir.
Basically, this is the first coefficient, this is the second coefficient, this is the third coefficient. This is going to be coming out equals to the power n. Okay?
Okay, sir.
Actually, it goes something like, what is C naught meant to say? N C R you have to get, right? So it is nothing but n factorial divided by 0 factorial, what you have, n minus 0 factorial. Isn't it? This was the thing.
Yes,
So
sir.
what you are doing here is you are simply doing n factorial divided by n factorial plus n factorial divided by n minus 1 factorial plus n factorial divided by 2, there should be 2 factorial, n minus 2 factorial, and so on till where n factorial divided by n factorial itself, n minus, I think it should be n factorial. This is what we are doing, and the result comes out to be to the power n. Okay.
Yes, sir.
If you want proof, should we solve this to get the proof of it?
Yes, sir.
Okay. So what we can do is basically, let's not go for the proof. We should not go in this way, okay? Because we are not going to get the answer if we go by this. Clear?
Yes, sir.
Um, let's use another method to get the proof. What is the proof? We already calculated this method. This becomes easy for us to calculate.
Yes, sir.
Okay. So what is this in this case? It is nothing but n c to the power 0 plus n c to the power 1 plus n c to the power 2, so on. till where you can have n c n. Is it?
Yes, sir.
There is one more thing, like one was already n, so it doesn't make sense. We had next thing is x n minus 1. But what if I tell you that do one thing, put x equals to 1 itself? I am saying put the x equals to 1.
Yes, sir.
If you put x equals to 1, I'll be having 1 plus 1 to the power n, and here whatever, like the next the expression should be something like ncr 1 to the power r 1 to the power n minus r. So it doesn't make sense, right? So I have directly written like this.
Yes, sir.
Is it? Did you got your answer?
Yeah, I understood, sir.
1 to the power n, so 2 to the power n. Very simple derivation.
Yes, sir. Got it, sir.
Clear?
Yes, sir.
Look, it doesn't depend upon any another factor. It directly depends upon n0 because the formula remains same. Whatever another separate like combined expression you have or not along
Yes,
with
sir.
this. Okay. So that's the thing for the binomial in general.
Yes, sir. Got it.
Okay, and another factor I can call it as this was the one property. The second property is if you have something like C naught minus C1 plus C2 minus C3 plus C4 minus C5, so on. Okay, till where you will be getting till n. It will come out to the zero. Okay.
Okay, sir.
Mm, you can assume this one by taking all these coefficient as a same time, like C naught plus C2 plus C3 plus what is this C4, right? And so on till some you can say n by and 2n value. Okay, subtracted with C1 plus C3 plus C5 till where you can go
Still see, like,
C2n minus 1, I can say. Is it?
yes, sir.
Basically, I'm taking a 2n minus 1 because I wanted an equal values, right? So that I can have some addition and at last I can have some subtraction. Okay. Now, if in this case, if you see carefully, which values I have,
So then in the even ones, C3 should not be there, right?
look, in the even ones, okay, yeah, I forgot this. It should not be here. Can we do one thing? Whatever the values are not present here can be add and subtract. For example, whatever they are not presented, for example these things, can I add here?
Yes, sir.
Okay, so I'll just add them. C1 plus C2 plus and okay, C3 plus and so on. If I added there, what I had to do,
Subtract something.
I have to subtract it from here also. C2 plus it should be C1 yeah, okay. Wait, it doesn't make actually sense whatever we are trying to solve it. For this derivation, we can use, I think we can use this method itself.
Yes, sir.
Okay, how we can use? What we are going to, we can do is, we can extract this portions first. Okay, we can make one combination of these. Okay, and in a similar fashion, we can have another format also.
Yes, sir. So otherwise, we
Okay,
can use the Pascal's triangle.
what happened?
So otherwise, we can use Pascal's triangles, like they're symmetrical, right?
Wait,
But even
your
like,
voice is a bit low, I think.
so like we can use Pascal's triangle, right? Like the for the even numbers that
Yeah, basically the best idea we have to do that itself. Okay,
yes, sir.
because of the Pascal triangle. Okay, the best thing is we can do the Pascal triangle. The symmetry gives us, right.
Yes, sir.
We know if something is present here, there's something equal present that side also, right.
Yes, sir.
If someone remembers that Pascal triangle, okay, if I have something here, I'll be having something here also because there's something on the center. So if something is in here like odd, here it is in the even side. Yeah,
Yes, sir.
that becomes minus plus. will result out to be the 0.
Yes, sir.
Clear? But yeah, in this case, one should be clear that n should be whatever n you are going to get, the whole thing should be come out to be um, even, so that you can have a negative and a positive present. For the same value, minus 5 is present, you need another 5 also.
Yes, sir.
Clear?
So, but for
You
odd
know, no, odd one it is not possible, right? I'll just maybe in the Pascal triangle, if you go back, where it is. Yeah, for example, if I take this as a Pascal triangle, I have this to get cancelled with this, right?
yes, sir.
But I don't have anyone to get this.
Yes, sir. So it's not applicable for odd, like even powers.
So no, actually it is not the case. Okay, better to go with this also. What was the formula here? It is applicable for all, okay? But the thing is, how they are going to get subtracted. For example, here if I ask you, C0, is it equals to 0? No, it won't. At least you need two values to get to use that theorem, whatever we are doing here. Okay? Alright. Now let's go back. Because 0 power it won't work. Okay? Leave it. C0 is there. What was the next thing? Minus C1. 1 get cancelled out. Is it clear?
Yes, sir.
Okay, let's check here. C0 minus C1 plus C, what is this? C2, right?
Yes, sir.
This and this results out minus 1. This is 1 itself. Results out 1. Again 0. Makes sense?
Yes, sir.
Okay. Now here, if you go with this side, this is C0 minus C2, C1 we can say, plus C2 minus C3. So what happens basically? When you have even things, na, you get a proper pair to cancel out. But when you have odd, you need like summed up from here, summed up from here to get cancelled out. Is it clear?
Yes, sir.
So that is why it is not possible. Like you can see here, this is negative thing, this is positive. Get cancelled by itself. This was the negative one, this was the positive one. Get cancelled by them. But for this case, what you have to do, you have to get some half of the sum from here, and you have to make it nullify with this part. Clear?
Yes, sir. Yes, sir.
So basically, it's a simple thing. If you put negative, positive, negative, positive, negative, okay, and if you get the result out of it, you are going to get it. Clear?
Yes, sir.
Pascal's triangle you can use at this point.
Sir, is there a derivation for the even powers, like odd numbers?
Derivation for the even numbers means
Like for like if we have odd numbers in the Pascal bracket, like odd number of coefficients, and is there a derivation for that? Like why is it zero?
no. I've shown you right. Look, the the derivation is the Pascal's triangle itself. Okay.
Okay, sir. Okay.
Okay. Look, which one you want to take? We'll take this.
Like power four. If we take power four,
This
then
one, right?
yeah,
Okay. Let's go back in the down somewhere we had space. Okay, here let's see. One, one was there, four was there, six was there, four was there, one was there. Negative, positive, negative, positive. Here, what happens if I say what is the net result out of it? Minus three.
minus three.
What is the net result out of it? Minus three.
Yes, sir.
What is this? Six. So basically, what happens? Whatever you are going from the right half, whatever you are going getting from the left half, the summation of both will be equals to the middle term. Is that clear?
Yes, sir.
But in the opposite sense, if you use this method. Clear?
Yes, yes, sir.
Alright, so that's the thing. You can assume in another sense now, like if this could have been made into the positive, what will happen? Okay, it was I think minus 4. If I ask you, this is the center, the middle term, both are equal in the sense, right?
Yes, sir.
If I had to write it in the equal, so what I could have got in that case, I'll be like 1 minus 4, again plus 3, and next one should be minus 3, right?
Yes, sir.
No, but this is the plus, so we are going with the plus. Basically, this is single thing. We are writing into the two term, okay? Minus 4 plus 3. So now if you see this is the minus 3, resulted with this comes out to be 0, minus 3, resulted with this comes out to be 0. Clear?
Yes, sir.
So that's the thing. Okay. Um, I think these are more than enough properties. Okay, I don't think you'll get some other problem based on this.
Okay, sir.
Clear?
Yes, sir.
Okay. So yeah, one more thing we can write. You know what is C0, C1 plus C2, 2 to Cn, right? That is 2 to the power n. If
Yes.
I extract the odd ones, for example, if I write it like C0 plus C2 plus C3, no, C4 dot C2n. So what it will become? It will be basically 2 to the power n minus 1. It is also equals to C1 plus C2, C3 plus C5. 2 to the power, whatever I can say, C to the power 2n. Is that clear?
Yes, sir.
The reason behind this, look, you know the total thing, right? It is equals to the power n. You know odd and even results you to the 0. It means they both comes are equal also.
Yes, sir.
So if I remove it, it means I'm dividing the whole thing by 1, by 2 basically. So it will result of 2n minus. Clear?
Yes, sir. Clear, sir.
So these three properties I think more than enough for you to remember in this chapter. Okay.
Yes.
If you like, if you're solving problem, if you get some new property, then you can it at that moment itself.
Okay, sir.
Clear? Okay. Wait. Maybe one more property on the basis of R we can have NCR plus NCR minus 1. Let's
I have
calculate
a
this.
sir. I have a doubt in the above question, sir.
This one.
Like, yeah, this above one. Should it be like the third property, like C not like C0 plus C2 plus C4 so on till C 2n, right?
Yeah,
So,
2.
okay, yeah, clear, sir. No.
Basically, look, 2 and I'm just writing 2 and to show you that we have even. Let's not write 2 and here. Okay, let's not write 2 and for a better. Because we can have odd term also. It is not necessary that we all will always be having 2 and. I
Yes, sir.
showed you that it will also work for the odd
Odd,
also, right?
yes,
When
sir.
the numbers are not even, still it's working. So it's better not to write this 2 and. Okay.
Yes, sir.
I started taking example of even, so that's why I am using this 2 and part.
Okay, sir. Got it, sir.
What is this? It is nothing but n factorial divided by r factorial and n minus r factorial, right?
Yes, sir.
Plus n divided by r minus 1 factorial. And what is this part? N minus r minus 1. Is it?
Yes, sir.
Okay. Can I write this thing also n divided by r, and this will become r minus 1 factorial of r, and it will become n minus r factorial of what is it? It will become this n minus r minus 1 factorial. Isn't it? It can be written as.
Yes, sir. Yes, sir.
Now if you see, I have whole of this component in this part. So can I take the whole thing as a constant itself?
Yes, sir.
Okay. I'll just try to take that as a constant. So what I'll left with, okay, first write this expression again, r minus 1 factorial n minus r minus 1 factorial. Okay. If I take the whole thing as a constant, you can see n factorial r minus 1 factorial n minus r minus 1 factorial. What I am left with? You know, I am left with 1 by r and this portion n minus r plus 1. Is it?
Yes, sir.
Okay. What? further can it be solved into? Okay, what is this portion? What this portion looks like?
So the coefficient of R, like the Rx term.
Coefficient, no, no. Isn't it the R? What was that? NCR minus one itself.
Yes, sir.
Let's take a look at this.
Yes, sir. Yes, sir.
Okay. Okay. Just, now just go back into this and uh, okay. Wait. We, we took some unnecessary thing outside. I'll just go back. Alright. Okay, till here I think everything is clear. Now what I
Yes, sir.
wanted to say. What I what I wanted to say. If you see, it can also be written as this n minus r minus one thing can also be written as n plus one minus r. Is it
Yes, sir.
right? Here also this can be thing. So isn't it looking like I am doing the factorial of n plus one
Yes, sir.
with
Yes.
respect to r? Okay. So where it is, yeah, let me rewrite the thing, whatever it is. Let's rewrite the same thing in another format. Okay. So this
Yes,
is n factorial divided by what if we have r. I already had r minus one. Okay, I'm not writing that thing again. R factorial, let it be. It is n minus r minus one factorial. Okay, maybe like this. So
into n minus r, right, sir?
I think yeah, it is this, and it should be n minus r minus one, right?
Yeah, factorial. Yes,
Factorial
sir.
plus n factorial divided by r minus one factorial n minus r minus one factorial. Is it?
Yes, sir.
Now, if you see, what is this term? This term goes as n factorial divided by r minus 1 factorial n minus 1, this becomes plus minus r factorial, isn't it?
Yes, sir.
Okay. Now, what I need? I wanted to make the whole thing into this. What idea I can represent here? You know, with this, what I had here, let me check some questions I can make. Okay, fine. I think this will not work. You're missing some point. Okay. Look, we are missing this property by some point. Um, what time I think? Okay, we can cover this part and see where Bhavish, Bhavish.
N plus, like NCR plus 1.
Yeah, look. Wait, let me check where we had missed. Okay, let's do one thing. Let's start. Okay, let's erase whatever I have written. I have done some mistake here, I know. That's why I'm not getting the proper derivation of it. Kind of is it? Okay, look, I'm writing this again here. Okay, what derivation we are going to do? This plus C R minus 1. Is it? We are trying to extract the expression for this one. So what's
Yes.
the method we can use? What is the best method we can use to calculate this derivation? The idea behind this is, mm, I think, should we do RHS equals to LHS? No,
Sir,
I don't
like,
think. No, no, wait, leave it. We are not supposed to do RHS equals to RHS. LHS equals to RHS. Okay. Look, can we do something like this? Where it is? Look, something like this. Just a second. Like whatever we were doing in earlier cases, that was also correct. Okay. So just first of all, get the formula out of it. N factorial divided by R factorial. N minus, yeah, quickly come to the class. Okay. Yeah. So here it was n minus 1, right? N minus R. No, no, ठीक है. Okay, hereafter we have to represent the next one. What it will be? It will be basically n factorial r minus 1 factorial, and make it clean this time. You know why this becomes like it was n minus this r minus 1 was already there, right? So it was written like this. I have represented this.
yes, sir.
Clear?
Yes, sir.
This is just a representation of it. Now the whole thing can be read as what? N factorial divided by, I think let's expand this one, r minus 1 factorial. Okay, you'll get the reason also, because look, we will try to extract whatever maximum we can extract it out.
Yeah,
Okay,
okay, sir.
maybe. Okay, so this thing n factorial divided by r minus 1 factorial. Now this was the one thing, right? You know, for the next I need to subtract 1 to get the next factorial, so isn't it look like this? Plus 1 minus 1 factorial.
Yes, sir.
It will this portion will get reduced. Now can you see, like we had too many things which we can take n, r minus 1 and this part, basically this and this portion, these three portions are there which can be taken outside.
Yes, sir.
Is it? Okay, so we will try to take this outside, then we will see which new thing I can make. Factorial divided by r minus 1 is the factorial, I think, which I was seeing there, and minus r is also. What I'm left with inside? I think the only thing is 1 by r, is it?
Yes, sir. That's it.
Plus 1 by n minus r. So no, just resolve it. Okay, when you resolve it out, what you are going to get?
N plus 1 by,
It will become n minus. Okay, whatever it is written, let's rewrite the same thing. Okay, if you solve this, what you are going to get? N minus r plus 1 plus divided by r. Here it is n minus r plus 1. Is it?
yes,
This got cancelled. Can you see this?
yes, sir.
Okay. So what we are left with finally, n plus 1 n factorial divided by, I have r factorial. Okay, I have r minus 1 factorial. Okay. And what else I have? N minus R plus 1 basically. N minus R factorial. Is it what I have left with?
Yes, sir.
Can I write the whole thing as N plus 1 factorial?
Yes, sir.
This thing can be written as R factorial.
Yes, sir.
Okay. Now what? And you know this is nothing but
N minus
N
R
minus
factorial.
R plus 1 factorial,
Yes, sir.
right? Can be rewritten in another format, that is N plus 1 divided by R factorial was already there. N plus 1 minus R factorial.
Yes, sir.
Isn't it looking like N plus 1 CR I'm looking for?
Yes, sir.
Okay. So here the final equation looks like N plus 1 CR. This is the fifth or fourth, whatever. Okay. This is the fourth basically you have property.
Yes, sir.
Okay, that's these four properties are more than enough for the binomial theorem to solve all the problems.
Okay, sir.
Any doubt you have?
No, sir. Clear.
Okay, where you have doubt?
No, sir. Clear,
At
sir.
which step basically?
It's clear, sir.
It's clear, right?
Yeah.
Okay, it's
Yes, sir.
clear. Okay. Okay, yeah. You were saying something.
No, sir.
Okay, everything. We can end wrap up the session here.
Okay, sir.
What?
Sir?
No, I should the new chapter, like it's a bigger chapter. Okay, the complex number.
Oh, okay. Okay, sir. Sir,
So yeah, like, do you want to solve problem? Like, I think we have solved only for the first part, right?
yes, sir.
So you can check in.
I didn't know the second part, sir. I
Okay,
didn't pass my theorem.
okay. So better to okay. You can just do the first part first. Okay, then after that, in the tomorrow's class, I'll start with the set complex number. Okay.
Okay, sir.
After completing the complex numbers, okay. Have you solved the relations and functions?
Yes, sir. I didn't. I went to the NCRT part, sir.
Uh, so should I have to take a class for those relations and functions?
I think I understood them, sir.
Okay, so let's do one thing. Take put it in the last priority, okay, bottom. So when we'll be doing majority of the chapter, after that I'll take that once the relations and
Relations.
functions.
Okay, sir.
Clear?
Yes, sir. Okay, sir.
So that's all for the today's class. I will you will get the PPT. 10 to 15 minutes, maybe like 5 minutes also. Okay. So yeah, that's all for the day. If you have any doubt, you can let me know. Others.
No, sir. I got everything in binomial theorem from NCRT.
Okay.
Yes, thank you, sir.
I think your voice is lagging. Okay, that's my network issue. Um, okay, I think now it is fine. Tell me like what's your doubt?
No, sir. I got everything from NCRT, sir, from binomial theorem. Like the
Okay,
ones which are.
yeah, like a binomial isn't too much. It's like basic your expression and all. It is used in another chapter all. That's the main thing. Like NC in another chapter, you don't have to use the properties. Mostly you'll be using PR and PR. That's
Yes, sir. Yes, sir.
okay. So, yeah, that's all for today.
Okay, sir.
I'm ending the session.